You ever see a modern fighter jet and do a double take? You look at it and think, wait a minute, are its wings on backwards? It's a design that just looks fundamentally wrong, but what if I told you it might just be the future of flight? Let's get into the incredible story of the wings that fly backwards.
So what's the deal? Why would you put these little wings, they're called canards, up at the nose of a plane instead of having a normal tail at the back? Well, the answer is this amazing story full of trade-offs, incredible technology, and a little piece of aviation history that most people have completely forgotten.
You see this super futuristic-looking design? It isn't new at all. Not even close. In fact, it was there right at the very beginning, on those windy sand dunes at Kitty Hawk.
Our story kicks off with maybe the most famous pioneers of all time. Because as it turns out, the secret ingredient to the Wright brothers' success was this exact wings at the front setup. That's right, the 1903 Wright Flyer, the first successful powered airplane in history, was a canard design. Those two horizontal wings you see sticking out the front, they weren't just for looks. They were the absolute key to making the whole thing work.
So why on earth did they do it? Well, it all came down to one word: control. The canard gave them incredible power over the plane's pitch, its ability to point the nose up and down. And this was a life or death feature. It stopped the plane from going into the catastrophic nosedives that had literally killed other early aviators. The Wrights wanted the pilot to fly the plane, to be in active control, not just hang on and hope for the best.
Okay, but hold on. If this design was so revolutionary, why did it just vanish for almost 70 years? Well, that brings us to the rise of the conventional tail, and why a supposedly safer design completely took over.
The very thing that made the canards so brilliant for the Wrights, its incredible responsiveness, became its Achilles heel. As airplanes got faster and faster, that lightning-quick response turned into a terrifying instability. It made the aircraft almost impossible for a human being to handle.
So let's break down the physics here, because it's actually pretty cool. With a canard design, the aircraft's center of lift is in front of its center of gravity. What that means is the plane naturally wants to tumble end over end. It's inherently unstable. A normal tailplane, though, that's totally different. It acts just like the feathers on an arrow or a weather vane. It's behind the center of gravity, so it's always pulling the aircraft back into a straight line, keeping it stable.
And this all boils down to this crucial concept in aerodynamics called static stability. Just think of it like this. If a gust of wind bumps a stable plane, it naturally wants to fix itself and get back on course. A tailplane gives you that safety net. A canard design, well, it rips that net away.
And this quote just nails the Wrights' whole philosophy. Remember, these guys were bicycle builders. A bicycle is completely unstable by itself, right? It just falls over. But with a skilled rider, it's perfectly safe and incredibly maneuverable. They just applied that same exact thinking to their airplane.
But in the end, the world wanted planes that were faster and easier to fly. So by 1910, even the Wrights themselves had caved. They switched over to the more stable tailplane design for their new military and commercial planes. And just like that, the canard was gone.
But then, after decades of being nothing more than a historical footnote, the canard made this huge, dramatic comeback. And it was all thanks to the computer revolution.
See, the problem was always that a human pilot's brain just can't react fast enough to control an unstable canard plane at high speed. But what if the pilot wasn't the only one doing the flying? As this research paper from 1999 points out, designers were now building modern combat aircraft to be intentionally unstable.
And here it is. This is the absolute game changer: fly-by-wire computers. These onboard systems can make thousands of tiny corrections every single second, constantly taming that aircraft's natural desire to go wild. And in doing that, they transform a dangerous flaw, instability, into an unbelievable weapon: radical, mind-bending agility.
So now that computers could tame the beast, engineers could finally let the canard off its leash. But how exactly do they work? What's the real science behind this incredible comeback?
When it comes to military jets, it really boils down to three key advantages: using that instability as an asset, getting way more efficient at supersonic speeds, and a really cool bit of what you could call aerodynamic teamwork.
So first, that instability. Since the airplane is already on the very edge of tumbling out of control, it takes almost zero effort to nudge it into a turn or a climb. This lets pilots pull off the kind of instantaneous, aggressive maneuvers that are absolutely essential in a dogfight.
Second, efficiency. And this is especially true when you go supersonic. See, to keep a plane flying level, you have to trim it with small adjustments. On a conventional jet, the tailplane has to push down to keep the nose from pitching up. It's basically fighting against the main wing, and that creates drag. But a canard? It pushes up. It generates lift just like the main wing. They're working together as a team, which slashes the aircraft's drag.
And finally, we get to my favorite part, this idea of aerodynamic teamwork. The canard doesn't just make its own lift, it actually helps the main wing do its job better by messing with the air that flows over it. It's genius.
Okay, so here's how it works. The canard creates this powerful, swirling tornado of air, a vortex at its tip. This little tornado then spirals back and flows right over the top of the main wing. When it hits, it basically re-energizes the airflow, and it makes the main wing's own vortex even stronger. This keeps the air stuck to the wing, even at really steep angles. The result? The plane can avoid stalling and can pull off some truly incredible high-G maneuvers.
But look, in the world of engineering, there's no such thing as a free lunch. Choosing to use a canard is a really complex compromise. It's a true engineer's dilemma, with some major pros and some pretty serious cons.
So, to wrap up the good stuff, you get that jaw-dropping agility thanks to controlled instability. You get way better efficiency at high speeds because you're cutting drag, and you create extra lift that lets you push the plane to its absolute limits.
But on the other side of the coin, the trade-offs are huge. You are 100% dependent on these incredibly complex and expensive computers just to stay in the sky. The canards themselves can actually block the pilot's view when looking down. And sometimes, that turbulent air they create can mess with the very wing they're supposed to be helping.
Which really just leaves us with one final big question. We've watched this design go from being a necessity for the Wright brothers to a liability that almost got it killed off, and now back to being a high-tech weapon thanks to computers. So as those computers get even faster, even smarter, and even more powerful, you have to wonder, is the good old conventional tailplane destined to become a relic of aviation history?